Welcome back. In this video, we will see the code walkthrough. So, we will be explaining step by step what is the purpose of the code and what it is doing. So, let's get started. So, here you can see Spark import libraries read data from Kafka. So, overall goal to consume clickstream events from Kafka topic, that is clickstream data, clean and transform the data and write into a Parquet file for further analytics. The step by step percentage Spark indicates it tells Zeppelin to use Apache Spark interpreter for the code that follows. Importing required libraries like SQL, type, function, and implicit. Type is used to define to manipulate column data type. Function is used for built-in Spark SQL function like split, trim, to timestamp, and implicit is used for implicit conversion to enhance data frame functionality. Read data from Kafka. So this portion is to read data from Kafka. It subscribes to topic clickstream data, that is clickstream data, and offset starting offset earliest to ensure the starting read from the beginning of the topic. We are doing it from beginning of the topic because we are loading the data into Kafka. We don't have any we don't have continuous streaming. We are doing it part by part by transferring file from one by one. So that's the reason we are only running this job once a day. So starting offset earliest, the result of Kafka metadata, that is key value topic, etc. We only care about the key value part that contains our CSV lines. So let's move further. Defining columns. Here we are defining the column names. The array defines explicit column names in the clickstream CSV. It is used to later to map CSV fields to column names. So that's why all 19 column names are written. Parse Kafka values into column. So the value passed equal to Kafka stream. Select expression cast value as string because it is by default byte. Cast value as strings converts Kafka values. Kafka data is in key value format. So we are only interested in the value which is in bytes. So to make it readable as a string. So that's why we are using it. Then we have split CSV into individual fleet using the regex that express codes. So this is the regex expression. Filter will ensure only rows exactly the expected number of columns 19 are processed. So this helps ignoring malformed rows. That is incorrect rows are ignored. So next step is to structured value apply schema to split columns, that is assigning column names. This assign meaningful name to each column a column with column function. Uses get item index to extract each value from the array and assign it to the right name, and drop cleans up intermediate files. So this is filtered stream is used to remove the header, CSV header. CSV generator includes a header row, which we have user ID, session ID, all those things. We need to filter it out. So this lines filter is out, doesn't populate the actual data. So type conversion and time formatting. So few of the columns are in string format. So we are converting it like scroll depth, time spent, seconds, transactions, signups, and event timestamp to timestamp format of YYMM, DDHH, MMSS format. This block casts important numeric fields from string to integer. It also converts raw timestamp appear properly timestamp column event using a fixed format YYMM, DDHH, MMSS, that is year, month, date, hours, minutes, and seconds. So now here step now we are over here. Write to parts defining the output paths. So these are the two paths. Final storage for transformed uh, clickstream data will be stored in the Parquet output path, which we have seen, and checkpoint required for stateful streaming to recover from failures. So this is for Spark streaming specifically. Checkpoint. It is used for recovery. For example, if our streaming fails, it helps us to recover from the failure. Write stream to Parquet. So this is the code that writes stream to Parquet. So writes the transform stream continuously into Parquet file. Append mode means new rows are continuously written as they arrive, using checkpoint to manage offset and fault tolerance. So the summary of this code is Spark Streaming, Kafka source reading real time streaming streams data, CSV parsing converts delimited string into structured column, cleaning filter out malformed and header rows, casting typecasting means converting string into ints and timestamps, storage persist process data into Parquet format for analytics. So, so here we will go to Spark core. Here we have defined a data frame, which name is Parquet DF. This is the Spark code which we are using. It will read the Parquet file, and here we have defined the JDBC connections, table name, Clickstream data, database user root, password, and this Parquet file will be written from at JDBC URL, database table and password. So the table name is Clickstream data, and it will load the data into MySQL with mode as append, and the data will be saved. The data frame saves data frame to MySQL. So here you can see logs DB. It is the database detail. You might remember we have used logdb in MySQL when we logged into MySQL. So logs DB is the log database, and this is the clickstream data, which is the table name. So the data stream data will be from transmitted from the Parquet to MySQL. So that's the code about Spark core. Now we will talk about the SQL statements. Here you can see daily user sessions. So this is the SQL. Select date event timestamp as visit date. Count as distinct session ID from total session from clickstream data. Group by date event time order by visit data. So extracts the date part from the full timestamp. So date event timestamp, it only extract the date part. Count unique session per day. group by date, data by date, and order by visit source result chronologically. So second is session duration distribution. So here we can see calculate session duration in seconds, timestamp difference, session ID, timestamp difference between in seconds from session start time and session end time, and group by session ID, session uh, start time and session end time. Ensure one row per uniqueness. So that is for the second SQL statement, which we have seen. Now, third, top landing pages. Refer URL is not null. Assume first page is session has not null uh, referrer or can be redefined further. Count star how many times a page was landed. So here is the SQL. URL visited count star as landing from clickstream data where refer URL is referral URL is not null, and group by URL visited, order by landing descending for limit 10. So group by page visited, list by top landing pages, for that is the order by clause, and returns the top 10 by using the limit 10 function of SQL. Top page, top exit pages. The user which left the pages. So we are trying to find out on which page it was the last page of the user who left the website. So select exit page, count star as exit page from clickstream, group by exit page, exit order by exit descending limit 10. This column expect to capture the last page of the session. So we are using the exit page. Count star counts how often a page was the last in the session, and order by descending limit 10 shows the most common exit pages. Fifth SQL query is more common click paths. So the SQL is select click paths, count star as path count from clickstream data, group by click path, order by path order count descending limit 10. Click path represent a string of sequence of URL action per session, that is home, product, cart, and counts how often the exact page appears, and order by path, sort descending sorts by frequency. Limit 10 will list the top 10 paths. And the last query is button click frequency. Select button click as count star from click count. Button click is also a column in clickstream data. So here you can see where button click is not null and button click is not equal to space. Filter out empty or null entries. Group by click button, that is group by distinct button combination like buy now, add to cart, and count star counts how often each type counted. Order by click count descending limit 10. So it shows most clicked buttons. So that's all for this course or this free project. See you with the another free project soon. So that's all for this lecture. See you in the next video.